Good evening, my YouTube viewers. It's Crystal here. I just wanted to do another code review with you because I got an algorithm to determine accuracy from scratch. And what I wanted to do is I wanted to go over that with you. So I've got two algorithms in my little Google Colab Jupyter notebook, and we'll go over both of the algorithms just in case you didn't see my first video. So the first algorithm that we have to determine accuracy from scratch, we're going to import NumPy as NP, and NumPy is a numerical computation library in Python. And so we're going to define y_val is a series of numbers from 1 to 20, and then we're going to define ypred as a series of numbers from 1 to 20, but it's not quite exactly the same as yval. I wanted it to be a little bit different. So we do correct pred equals 0 for I in range len yval. If ypred I equals yval I, correct pred equals correct pred plus 1, else correct pred equals correct pred plus 0. And then so when the for loop has finished its iterations, score equals correct pred over len yval. And then you print your accuracy score of 0.7, which is 70%. And this is the second method that I have to determine accuracy. It's a little bit different, but it does the job. So we're going to import NumPy as NP, which is your numerical computation, and yval is the same as the yval in the previous cell, and ypred is the same as ypred in the previous cell. So, and then we're going to create a function called def accuracy. So def accuracy, it takes inputs ytrue and ypred. So accuracy equals np.sum, brackets np.equal, brackets ytrue, comma, ypred, brackets, divided by len ytrue, and it's going to return the accuracy. So accuracy equals accuracy, yval, comma, ypred, and then you print accuracy, and that's going to give you 70% as well, 0.7. So now we're going to go over how to calculate RMSE, which we've already done that in the past, but since I've got this formula on my Jupyter notebook, I'll go ahead and cover it anyway. So root mean squared error is a frequently used measure of the difference between values predicted by a model or estimator and the values observed. The RMSE represents the square root of the second sample moment of the differences between predicted values and observed values, or the quadratic mean of these differences. So we're going to import NumPy as NP. Yval is going to be the same array as the previous two examples, and ypred is going to be the same array as the previous two examples. So MSE equals np.square, brackets np.subtract, brackets yval, comma, ypred, brackets, dot mean, brackets. And so you're going to print your MSE, which is .45. And RMSE equals np.square root, brackets MSE. You print RMSE, and the RMSE is 0.67. So in the past, I had as the square root, I had math as the square root, but whenever I was going through codes and things, sometimes math didn't work. And I was reading a Stack Overflow question because some other people were complaining that math didn't work, and there's a glitch in the math program that means it doesn't work. So I stopped using math, which is an inbuilt Python programming, inbuilt Python library, and I'm just using NumPy if I can, because NumPy seems to work where math doesn't. So that concludes this code review. You've learned about 3 algorithms, 2 of them to determine accuracy, and 1 of them to determine MSE and RMSE. So I'm going to go ahead and conclude this video because I think you've gotten all the relevant information that you need from it. And I would like to thank all of my subscribers who support my channel. If you like my video, please like, subscribe, and share. And thank you very much for watching this video. I look forward to making more code reviews for you in the future.